Related rates is a way to apply differentiation to real-life examples. So here we have such an example. Person B initially stood 3 feet from person A. B then started walking north at a speed of 1 foot per second, while A remained stationary. After B has walked 4 feet north, at what rate is the angle theta changing? So, let's start off by taking what we know. So we know 3 feet, and we know that the speed is 1 foot per second. So we'll start off by writing 1 foot per second next to the arrow. And then so it says that B has walked 4 feet north. So this distance is 4 feet. Since this distance is 4 feet, we can find theta using tangent. So we'll start off with an equation to find the angle changing. So tangent theta is equal to, we'll call this height over 3, because that 3 never changes. Okay? Which means that theta, we'll leave it like that because it's easier. Nah. Alright. We'll do this. Theta is equal to arctan h over 3. Now, the speed of 1 foot per second is also known as dh over dt, or the change in height over time, which is 1 foot per second. Okay? And h at t equals 4 is equal to 4 feet. Right? So now what we're going to do is we're going to differentiate both sides. Because when you differentiate in terms of time, meaning d variable or d function over dt or d time, that means that you're trying to find the change of this function over some change in time, which is a rate, and we're trying to find the relation between this rate and the rate of this angle changing. So theta is equal to arctan h over 3. So now we differentiate both sides. The derivative of theta is d theta over dt, which is the change in the angle theta over time, which is the rate at which the angle theta is changing, is equal to the derivative of arctan height over 3, h over 3. We know that the derivative of arctangent u, where u is a function, is equal to u prime over, which is the derivative of u, over u squared plus 1. Just like that. So, since we know this, we can differentiate arctan h of 3. So u is equal to h of 3, so u prime is the derivative of h over 3, which is 1/3 times dh over dt. Then we divide by u squared plus 1. U is h over 3, so that's h squared over 9 plus 1. So, now that we know that, we can simplify this. 1/3 times dh over dt. Well, dh over dt is 1 foot per second, so that's just 1/3 over h squared over 9 plus 1. We'll take out 1 over 9, so that's 1 over 9 h squared plus 9. Now, this simplifies to 1/3 over 1/9 times 1 over h squared plus 9. 1/3 over 1/9 is the same thing as 3, because 1/3 divided by 1/9 is 3, because 3 times 1/9 is 3/9, which is 1/3. So this means that this is equal to 3 over h squared plus 9. H, we know, is 4 feet. So that means that this is going to be equal to, that means that d theta over dt is equal to 3 over h, which is 4, squared, which is 16 plus 9. 16 plus 9, which is 3 over 25. So then we put our units. So the angle is in radians. So this is radians per second, because our unit of time is still seconds. And that's how you solve a related rates problem.